So we're going to kind of just describe each one of those three pieces, like groups of information, with the absolute value functions, and then today we'll try and look at graphing them by pain. Next week, on Monday, we will look at graphing just general graphs. It might not have a specific shape, but we're going to try and transform them. So we're going to talk about transformations with absolute value functions, but then we're going to just try and transform any kind of graph. And then next week we'll also be looking at something called piecewise functions. So I'd say the next, today, the next couple days, next week, we'll be doing a live graphing. So you have a test coming up next Friday for a notebook quiz, chapters 1 and 2, and then the following Monday will be your chapter 2 test. Just to get you started to think about that notebook quiz, your homework, try and start gathering it and getting it organized if it isn't already, because homework questions will be on the notebook quiz. So it's like an entire quiz on any warm-up that we may have done, any homework that you've had assigned, along with the notes that we take in class. So I'll remind you next week, but you'll get about 20 minutes to take the quiz, and some of you will need that 20 minutes because you can't find your homework, because you didn't take time to organize it. The notebook quiz goes in order from chapter 1 sequentially through the end of chapter 2. So if you have your homework in order by page number, that really helps, because all I tell you is to look at page 33, write down number 14. So make sure that you're looking at your homework assignments if you have a little time over the weekend, or start to do that next week, and I'll remind you again next week. All right, so if you look at the worksheet, the first group of equations, and these are all absolute value, so now we're looking at this new function trying to graph it, had a plus k with the problem. And that k was the number that was added after the absolute value, or possibly subtracted after the absolute value. Can anybody give me a summary as to what happened with their graph? So what happened to the graph when you had that plus 2, Julia?
The line moved vertically.
Yeah, so, and what was the shape of your graph?
Like a V.
A V, yeah. So the absolute value graph is going to look like a V. And so if there was a plus number in the back of it, so if it said the absolute value of x plus k, the graph ended up going up. So this number here makes the graph move vertically, but if it's a plus, that graph moved up vertically. So in your calculator, you would have seen a second graph inside of the first one. So when it's a plus k, we'll say the graph moved up. And you don't have to have those exact words as long as you have something to that effect. So the plus 2, the plus 5 made the graph move up. And then the third option said the absolute value of x minus 3. And that would have taken the graph and moved it down. So the minus part moves it down, the plus part moves it up. So today we're going to look at that further and try and do it without the calculator, just by knowing that that number outside the absolute values represents a part of the graph that's going to move it up or down. So plus moves it up, minus moves it down. So that was the first group, and that value is called k, and we'll talk about that k value. The second group of problems had numbers inside the absolute value with x. So this first one here, the regular y equals absolute value of x, that's still a v. But then you were asked to kind of see what happens with it if you have x minus 2, or what happens with it if you have x minus 4. Those look the same because they both have a minus inside. Anybody know what happened to the graph with those two pieces?
If it's a minus number, it moves the line to the right.
Yeah. So if we had the absolute value of x minus h, so that number inside is the h value, even though there's a minus there and you think minus usually means negative, move the left direction, in this case it doesn't. It's actually moving it to the right. So this moved our graph to the right. Which is kind of weird. But that's because it's inside these absolute value bars, and we need to actually do the opposite of what it's telling you to do. So even though it has a minus 2 there, you're really just looking at that 2. The minus is kind of part of the equation. That's part of the formula for this graph. It's the 2 that we're really focusing on. The other one says the absolute value of x plus 5. And Connor, that graph actually moved which way?
To the left.
There we go. This one actually moved to the left. And I want to talk a little bit about why that moves to the left. When you have a plus sign, what's another way that something can become a positive sign? Julia? A double negative, and that's what's really happening here. So this is really taking x minus and then a negative 5. Because the equation has a minus in it. So if I scroll back to the top of my screen here, it's going to work for me. There we go. The equation has this minus sign. It's like a formula. There's lots of formulas in geometry that you learned last year. So one of the formulas in math is to have this x minus h. Well, the minus is part of the formula. So even though it might say x plus 5, that's really saying you have x minus, because here's the formula part. The h value is a negative 5. That's why the graph is moving left. Because a minus negative 5, if we simplify it, it turns into a plus sign. So the graph is moving to the left because the formula piece always is x minus. It's just, we usually simplify things. We don't really say x minus a negative 5. We say x plus 5. That's really what it's talking about. So that's why the graph is moving in the opposite direction of what you think it should. Questions? So then if you flip it over, there was one last piece that you were kind of asked to investigate with the calculator. And that was placing a number in front. So that number is called A. So now we have an A, there's an H, and a K, besides the X and the Y. So we've got a lot of letters in this formula that we're looking at. But we kind of wanted to see like what happened to the graph. So if this is my regular graph, that's this graph right here, Y equals the absolute value of X. What happened to the graph when you plugged a 2 in? What happened to the graph when you plugged a 5 in? Both those numbers are bigger than 1. Can anybody describe, like look at the graph that you may have drawn on your paper there? What happened to that graph? If there was a 2 there, if there was a 5 there. What'd your graph do?
The slope changed.
Yeah, the slope changed. Do you remember if the 2 and the 5, did it go inside your V or outside the V?
It went inside.
Yeah, it went inside. So this number here changes the slope. It makes it steeper because this is rise over run. We're still talking about lines. We haven't changed our shape yet. But this slope is saying go up 2 over 1. This slope is saying go up 5 over 1 because I really could put this over 1. It's supposed to be a 1 there. And make it into a fraction. So your graph has the same point. They start at the same point. But if the number in front is bigger than 1, our graph, we say it gets steeper because the slope is getting steeper. So these make the graph steeper. Or you could say maybe more narrow. bigger than 1 in front of this absolute value represents the steepness of the slope. And because that's rise over run, our graph is getting steeper. So looking at the other graph that they gave us, or the other equation, it was 1/2 the absolute value of x. So what do you think happened if that would be a 1/2 absolute value of x? Julian?
That makes it wider.
Yeah, it makes it wider because I'm going up 1, but now we're going right 2. So we're rising 1, but we're doubling our distance to the right. So this graph would become wider. So if there is a number less than 1 in front, actually between 0 and 1, the graph actually is going to get wider. Again, this represents the slope. So you investigated 3 different things. One, how the graph moves up and down. The second was how it moves left and right. And then this last one was how the graph would become more narrow, or maybe it's going to get wider. And that's based off of the number in front. So we're going to see if we can try and look at those 3 pieces of information today and try and start graphing these by hand. And that's why I gave you graph paper, because tonight's homework from 3 to 14 is graphing these by hand. And I promise you're not making a T-chart. It will not take you very long to graph. But it's just like recognizing the information. How does it relate to graphing something by hand? So in your notes packet, if you could take out section 2.7. 2.7 is actually a really large section. So there's absolute value functions in it. There's transformations in it. Something about transformation, which you did last year with shapes. And then there's piecewise functions in it. So we're going to spend about a week on section 2.7 because there's 3 different pieces of graphs that we're going to be looking at. So section 2.7, it should have 2 pieces to it. Make sure you found the piece that looks like this. The section that looks like this looks like it's page 23. At the top it should say absolute value and transformations. So we'll do absolute value today, transformations on Monday. And then we'll kind of talk about piecewise functions. So a lot of stuff in this one little section here. So the first thing, can anybody kind of remind us what absolute value means, what it does? Holly, what does it do? Yeah, so absolute value is the distance a number is from 0. And we looked at absolute value equations in chapter 1. And we said that you can have the same distance with a negative 5 to 0 as a positive 5 to 0. So you have both sides of that graph, both sides of the number line. An absolute value function contains the absolute value symbol. And it looks like, has a lot of letters. A, absolute value x minus h, and then plus k. Those are all the letters that we kind of just went over with the little calculator activity that you did yesterday after your quiz. So an absolute value function must have an absolute value symbol in it to be an absolute value function. We're saying it's a function, therefore remember it passes the vertical line test. So if it's a function, each x has exactly 1 y. The vertical line test only passes through the graph at 1 point in every single location. So if you say something's a function, we're going to use this function notation here. So instead of just saying y, you're going to see f of x to represent it is a function. The last part here talks about the vertex of the absolute value graph. Anybody know what a vertex is?
Is it the highest or lowest point?
It is the highest or lowest point, yeah. So the vertex is either the highest or the lowest point of the graph. And there are a couple of different graphs that we'll look at that have vertex values. So if a graph looked like this, the vertex would be right here where the 2 lines are meeting. that vertex represents the letters h and k from our function. So we're going to be able to find the vertex. We're going to find that h and k value. That's going to help us graph it. So from this function, the h and the k represent the vertex. So the numbers in the equation actually help us graph it. So underneath, there's a little bit of a picture, a little guide to kind of get you to see what absolute value is. How does it look? So it talks about a parent function. We said a parent function was the most basic form of every function. So the parent function is just that f of x equals the absolute value of x, or the y equals the absolute value of x. That was every basic graph that you looked at in those 3 different sections. It says that it's a V shape and that it's symmetric about the y-axis. If something has symmetry, what does that mean? Or if it's symmetric about the y-axis, what's that talking about? Think back to last year's symmetry. Brock, do you remember what symmetry was?
They're equal on both sides.
Yeah, they're equal on both sides. So if you took that V and folded it in half, both sides should meet. You should have that line that goes down the middle, the line of symmetry. So what it says underneath here, for every point x, y, there's another point negative xy on the same graph. So essentially, if you have 2, 2, you would have negative 2, positive 2. So the same y value, that height's not changing, but to get the symmetry, you have to have a negative point on the other side. So we could do the same thing up here. This would be 4, 4, or I would have negative 4, 4. So whatever you have on one side, you have the opposite x value on the other side. And that makes things symmetrical. And then underneath here it says the lowest or highest point of the absolute value function is called the vertex. The vertex of this graph is at 0, 0, because it's not moving anywhere. So a parent function is the basic graph that is centered at the origin. It does not move left, right, up, or down. It's not going to get wider or more narrow because it's a basic graph to look at. So we're going to see if we can try and graph these. Before we get there, there's 2 different terms underneath. One term is a transformation and the other one is a translation. There are actually a bunch of different transformations that we'll look at. So a transformation is a shift. What else could you do besides shift a graph? How could it be transformed? Julian?
You could flip it with your axis.
Yeah, you could flip it. We usually call that a reflection. That's the math word. Reflect it, flip it. How else could a graph change? Odette?
Dilation.
Yeah, what does that mean if you have a dilation?
Changes the size.
Changes the size, yeah. So you change in size. I think you looked at those last year with shapes. So you can shift, you can flip or reflect, you can change the size. Anything else?
Rotate.
You could rotate it, yeah. Those are good words. So all those are called transformations. How does a shape transform? How does a graph transform? A translation is just a specific type. And a translation, we're talking about the shift in the graph. And a shift is how does it move? So does it move left or right? Or does it move up or down? So a translate is a slide. I think that might have been a word you used last year. How does the shape slide? Left, right, up, down. So that would be our translation. So there's transformations, a bunch of transformations, but a translation shifts the graph. It shifts it left, right, up, or down. Questions? So if you look at the top of the next page, we're going to see if we can start translating these graphs. Nope, not yet. I'm ahead of myself. Still a little bit more vocab. Talking about other transformations here, not just translations. So this one examines the last part that we looked at on the exploration, the calculator activity. So it says if the absolute value of A is greater than 1. So just so you know what that A is talking about. The number in front. That's A. That's our slope. So when they're talking about A, they're really talking about the number in front of the absolute value or the slope of the two lines. If that number is greater than 1, the graph is vertically stretched and is narrow, let's say more narrow, than the graph of y equals the absolute value of x. So it gets narrow, it gets skinny. But we say vertically, it's being like pulled, because you're going up more than you're moving to the left or to the right. So we call that a vertical stretch. So if there's a 5 in front, if there's a 7 in front, if there's a 4/3 in front, if the number's greater than 1, you're moving up more than you're moving left or right. So that's a vertical stretch. If the number is less than 1, the absolute value of it is less than 1, so we're keeping it positive, then the graph is vertically shrunk. And it is wider than the graph of y equals the absolute value of x. So if I have 1/2, 1/3, 1/5, 1/7, 2/3. So the absolute value of the number is less than 1. I'm only going up a little bit, but we're moving left or right more. So it gets to become a wider graph, or it's squished down vertically, so it's not going to be as high, as steep. And then the last one, the reflection. I can't remember, who told me a reflection? Connor, did you say reflection? I don't remember who. Julian, did you say reflection? Yeah, maybe. I think you called it a flip, right? Yes. Sorry. So reflection is a flip of the graph over the x-axis. So pretty much changes direction. So if my typical graph goes up, a reflection, bless you, or a flip is going to make it go down. So that same graph flips, reflects, it now faces downward. That's a reflection. Same thing as a flip. We give it a nice new name and call it a reflection.
Do they have the same vertex?
Yep, so it's going to be the exact same vertex, it's just going to flip down. So same shape, same point, it's just flipping down. Now I think we have a graph to look at. Alright, so it says graph the functions of the form y equals ax. So the first one we have graph y equals 1/3 x. 1/3 absolute value of x. So there's two things that we're going to focus on when we graph. One would be the vertex, the other would be the slope. That's the only thing or the only information that we need to know to make a graph. So the slope is the number in front. The vertex would be the values that are added or subtracted with this. In this case, if we don't have any number added or subtracted with x and any number on the outside being added or subtracted, the vertex is at the origin. So if there aren't any extra numbers being added or subtracted, the shape isn't shifting. Our graph is not translating, it's not sliding anywhere. So the vertex will be at 0, 0. So that's the one thing we need. We need to know where it starts. Everything is focused on the vertex. That's the highest or lowest point of the V. And then we're going to look at the A value. And in this case, the A value is 1/3. That really is your slope, because this is two lines that meet at the vertex. So the slope would be up 1, right 3. So we're going to try that. We're going to go to the vertex. We're going to go up 1, right 3. However, you're supposed to have two lines. And right now, if I connect these, starting at the vertex, connect my points, don't go beyond the vertex because that's where it starts. we have half of it. But we need to get the other half of the v. So if you go back to the vertex and you still go up 1, we need to move to the left because this is supposed to be symmetrical with the y-axis. So up 1, left 3. So we're moving up 1, right 3, but then we move up 1 and backwards 3. So we're always rising, but we're moving left and right. And the reason we're moving left and right is because the x value is supposed to be a positive x value and a negative x value. And remember, this number here represents a positive and a negative x. So if you want to think of that as having like a negative 3 down there to get that negative side. That's all you do to graph it. So up 1, right 3, up 1, left 3. Questions? So if you look at the next one, letter B, we want to graph y equals negative 2 absolute value of x. So the vertex, we still don't have any numbers being added or subtracted. So it's 0, 0. This time the a value is negative 2, and then I'm going to place it over 1. Gavin, can you explain how you would move with the negative 2? Yeah, so you're going to go down 2, right 1. So go to that vertex, down 2, right 1. And then you still need to make the x negative. So we would still move down 2, but now we need to move left 1. So back to the vertex, down 2, and left 1. Your shape should always look like a V. If it doesn't, then you moved wrong. So you're always moving in the same vertical direction. We moved down in both cases, and then we moved left and right to take account for that symmetry. The left and the right side having a positive and negative x. The last thing, it wants us to compare the graph with the original graph. So the original graph, I'll just draw one in, you don't have to draw that in there. How would it compare? So if there's a 1/3 in front, how does that compare to the original graph? What did we say about it? Julia?
The angle is much more.
Say it again?
The angle is like way more.
Yeah, so it's more open, he said. And we could say that this is a wider graph. You could say it's a vertical shrink, not going as high or as steep. So this is a wider graph. So when it says compare the graph, just explain what's happening with it. Besides graphing those first couple, you're going to also just describe what happened to the graph. So Eden, what would you say about number 2? Yeah, so it flips, and Eden, there's something else that happens. The slope is steeper. And it's steeper because this number here is a 2. So instead of just moving up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1, we're going down 2. So it flipped, and then it also became steeper. Or you could say more narrow. Questions? Alright, so let's look at the next piece of information here. Now we're throwing a whole bunch of numbers in. This one wants us to graph a function with an a, an h, and a k, and then again it says compare to the graph of y equals the absolute value of x. So we're going to first identify the vertex of the graph. The vertex would be your h and k values. Odette, what do you think? So Odette said negative 2, negative 1. How did you get those numbers, Odette?
The negative 2 came from the x minus h. It says x plus 2, so it's x minus negative 2. And then the negative 1, it says minus 1 for the k.
Nice job. So your h value is really a negative 2 because it's supposed to be x minus h. Well, if there's a plus there, that really means it's x minus a negative 2. So that's the h of the vertex. Think opposite of what you see when you have that h value. The k is the number sitting outside. So we're going to plot that point first. We're going to go to the vertex. It's now at negative 2, negative 1. So the h is the number inside with x, but it's really the opposite of what's sitting there. So -2, -1. So we've got the vertex. We plotted that point. The A value is the number in front, and that number is -3. I'm just going to place it over 1. So Maggie, how would you move with this slope now that we have the vertex?
You go down 3 over 1.
So down 3 over 1, or we would go down 3 and backwards 1. So you're moving down in both cases and going left and right. So down 3 over 1, down 3, backwards 1. Questions? Can anybody describe how the graph changed? So I went, describe the translation, the transformation. How did it change? How did the graph move? So usually it starts here and just has a slope of up 1 over 1. So how did the graph change? Julie?
It's steeper and it's flipped upside down.
So steeper, it flipped,
And it's also like shifted to the left.
it shifted to the left, and it moved down 1. So 4 things happened with the graph. It got steeper, it flipped, it moved left 2, and down 1. All of that would be describing the transformation of the graph, each piece of the graph and what it means. So the negative sign means something. The 3 in front means something. The 2 inside means something. The -1 means something on the outside. Questions? All right, so if you flip it, I want to see if we can go through like 2 more examples here. So example 3, I think it's the last type of problem that we're looking at here. You have a graph, and I want you to come up with an equation. And I wrote the equation up here again, y equals a, absolute value of x minus h plus k. What's one thing we need to write this equation? Julia?
The origin. Wait, the origin.
Yeah, the vertex. That vertex is your h and k. So -1, 3 is our vertex, which represents h and k in our equation. So we have x minus h, so that would be x minus a -1. K is a +3. So we're just plugging that information in. What else do we need? Abby, what else do we need besides the vertex?
The slope.
Yeah, we need the slope. How do you think you can get the slope? So we can do the actual slope equation, y2 minus y1, x2 minus x1. What else could you do without using the equation? The formula? Yeah, just look at the graph. See the rise over run. So starting at the vertex, and I made a second point on the other side here because it's symmetrical. Rise over run. How high? How far over? 1, 2, 3, 4 over 2. So we have 4 over 2, which just makes the value of 2. It's a line. You got 2 lines. We're taking the positive side of the line because it's moving up. So the slope is rise over run. It's going up 4 and over 2. Well, 4 over 2 is just 2. Questions? Right, so I'd like to graph one of those at the bottom there, just to graph one. We'll graph the first one again so you can get another one, feel a little more comfortable. So when you're graphing today, or maybe on Sunday, probably not tonight, I need you to list the vertex on, like, next to your graph, and list the A value. Can anybody tell me the vertex in the first independent practice problem? Emma, what do you think? Yeah, 1, 2. So H is 1, K is the 2 outside, and it's the opposite. So we're going over 1, up 2. Emma, what would the A value be then? Yeah, 2 over 1. So you're moving up 2 right, and then you're moving up 2 and left. So up 2 right, up 2 right, up 2 right. Mimic those same points on the left, and then graph your absolute value function. If you have a V that goes on its side and looks like an inequality symbol, a greater than symbol, a less than symbol, you didn't count up both times. You ended up counting like up and down instead of going up both times. So make sure you're going up, moving outward, left or right. So again, you have graph paper. Please don't just draw me a graph. Make sure you're listing the vertex, saying the movement of the graph. It moves left, it moves up, it moves down. Have an awesome weekend.